Okay, so we talked about properties of logs on Tuesday. It feels like eons ago since I last saw you guys. This funky schedule we have this week, and I think after this week, I think we're done with crazy schedules until the week of graduation. I think. Let me just double check the calendar here. Yeah, so like, I mean, there's APs, of course. APs will throw things askew a bit. But
do you know if like we have an AP, do we have to go to school?
Great question. It's always kind of confusing. So it's like if you have an AP in the morning, then I guess you don't have to go to your afternoon class, or it's vice versa. Or I think if you have an AP in the afternoon, you don't have to go to your morning classes because maybe because you're like you need to use that time to study. But if you have an AP in the morning, then you're expected to go to your afternoon. I don't know. I could be wrong, but I'll have to look at the student handbook. Yeah, but for pretty much next week, the week of the 22nd, the week of the 29th, the week of the 6th, the week of the 13th, all normal weeks. Then the 20th is should be fairly normal as it looks, kind of. And then we have graduation that day, so that things are, but I think the periods should be fine. And then in terms of the final exam, because I know we have some juniors in here, I think we're trying to have everyone do the final at the same time, so that way we don't have to do two different versions. This is a mixed class, as you guys know, mixed classes. I don't know what the percentage is. They do have to take because it's not a senior only class. Yeah, so like for example, you have Alex, Alexandra, Luca, Tammy, Jamie, Sean. Yeah, so we have like 6. So it's about half. You know, half you guys are seniors. So anyway, yeah, no, if it's a dominant senior class like non-AP calculus, non-AP stats, or any AP calculus, then yeah, we do the final before or during the senior final week. So anyway, that's all that. And let me close some other things here too. Okay, so properties of logs, we went over this on Tuesday. Here are the notes. Okay, you're good. I was like, okay, now I'm gonna take attendance. Actually, it's video evidence I did a slate. That's okay. It's not a big deal. I don't think anyone checks this. Okay, so we have no Jamie, no Logan, no Stella, no Liam, and no Chris. So wow. All right, so we got 4. Okay, good. That's it then. All right, here we go. Okay, now I can teach. All right, so anyway, log base 232, you guys show it's 5 because 2 to the 5th power is 32. Log base 9 to 27 is, now it's kind of a funky one. It's 3 halves because 9 to the 3 halves power equals 27 because you got square root 9, then cube it out afterwards. Or you could change both 9 and 27 the powers of 3. 3 is 0, 6 is 0 powers 1. 4 is 1/4 because 4 through 16 is 2. For 5 and 6, that's breaking it down, right? So if you have a fraction, anything that's up top is positive, anything that's down below is negative. So you put a negative in front of the x minus 5, but positive for the x plus 3 squared and positive for number 6. And if you have exponents next to the base, you got to move to the front. You roll it to the front. So that's what happens. For 7 and 8, more of the same stuff. Break it down. Now, if you can't evaluate, if it's possible to evaluate mentally without a calculator, do it. Log base 525 is 2. It's kind of weird because it's not really expanding. In some ways, it's kind of actually condensing, but whatever, it's fine. And then, of course, 8's pretty straightforward. I think that should be fine. And very important, in order to use log properties, the logs have to have the same base. 9, 10, more of the same stuff again. Again, anything that's at the bottom, make it negative. And if you have exponents, move to the front. If you have a radical, that is an exponent still, right? 4th root is 1/4 power, so it's still an exponent. 64x5 is actually multiplying 2 things, 64 and x5, so make sure you break that down as well. But I'm really more curious about the other problems, condensing, because condensing is actually more practical than expanding. Because when you're solving equations, or especially in calculus, like sometimes in calculus you might have to combine logs so you can actually do the calculus with it. Sometimes you do expand too. Sometimes that is a possibility, but for most part, condensing is more prevalent than expanding. So I'm more interested in condensing. So anything that's negative goes in the bottom, anything that's positive goes up top. And if you have a number, roll it back along the log to get the exponent there, and just make one big fraction of the log. And remember, in order to do this property, you must have all logs with the same base. Like this for log base 4, base 3, and base 2, forget about it. None of those can be combined, right? They have to have the same base for this property to work. Yeah, more of the same stuff here. All these answers I think are in school, G. Let me double check. Not, I have to take care of during the period today. This is a longer period. And actually, we didn't really do anything first 15 minutes. So now it feels like an hour-long class, but that's okay. Let's see. Do I have the answer keys up? I think I do. Solution keys. Yeah, I do. It's there. So good. Word problems, just plug and chug, not that hard, right? You start with 60 million people, but you do in terms of millions. Yeah, that's what's going on there. Anyone know what movie that's from? Good. Okay, good. Awesome. Why do you think the population is declining? They want no water, or maybe the evil empire came and destroyed. Yeah. Anyway, okay. You got late slip good. All right. Anyway, anyhow, that's what's happening there. And then it's declining. Yeah, we know that. And for 18, you got all that stuff. That's just finance formulas. Pretty easy to work out. If you're compounding monthly, that means the 6% gets spread out over 12 months, right? So, like for example, if you have a credit card with a 20% APR, which is absolutely insane, always try to negotiate if you can, or just don't max your credit card. That's spread over 12 months, but then you pay, still a lot of interest. So you want to be mindful about that. Tammy, go ahead.
Are you getting formula for that?
Let me find out. Maybe, I think so. I know in Algebra 2, actually, we don't, because we're trying to teach students how to use, exponential modeling. And I mean, for the most part, you should know an exponential model is like a initial value times a base raised to the power, right? The base has to get split because you're clearly splitting that percentage over 12 months. Or if you do it daily, you split over 365 days. Let me find out. I mean, I'm cool with it if you guys get it, because it is kind of wacky. I think 19 is even wackier. That's compound, even though it looks simpler. But that's compounding continuously. So the reason why we have E instead of the 1 plus R over K, so what's happening with that one? You're assuming that K is infinity. You're assuming that's infinity. And you have some percentage up here. But what happens is that this gets really tiny when K, because if you're compound continuously, it means that every regular number is being added to it. As I'm talking, it's just accumulating. But small amounts of them, very, very small amounts. So that's why that's infinity. But it makes that percentage, whatever percentage you're at, that percentage is getting chopped up in little pieces, right? So it's kind of a trade-off. So overall, this expression converges to that number. That number is 2.718. So that's what we have. And that's all. I think there's more to the homework. Sorry. This is just old stuff. Make sure you guys can grab exponential functions. That's exponential decay. You're given a table, so plug and chug. And the -4, you guys know, shifts 4 down. We know this. Domains, always all real numbers for exponential functions. The range will be limited depending on what the shift is for the vertical shift. And that is closely aligned to the vertical site. That's a horizontal asymptote, not vertical asymptote. That's a typo. It's horizontal. So, all right. We're all good? All right. So why don't you guys get the notes out? If anyone still needs a copy of the notes, please let me know. You still, okay. No problem. Extras here. Ready to I don't think that's
Way too.
no. All right. Okay, let's do the notes for today. Hopefully, it won't take too long. Wrapping logarithms, which can be somewhat painful because it's not as easy as exponential. But if you treat it like an exponential, it's actually not so bad. And there's some old stuff that we'll review, and then you have homework after that, and that's that. So hopefully I need about 20 minutes to do the lesson today. Shouldn't be too long. So remember, a logarithm is the inverse of an exponential function, right? So let's say you got 10 to the x. And let me plug in some typical numbers here. That'll be 1/10. That'll be 1, that'll be 10, and that'll be 100. Now, if you have log base 10 of x, so what happens is that what if you switch x and y? We know this, right? You switch x and y, and you have to get y by itself. If you get y by itself, it becomes y equals log base 10 of x, which is what we call the common log, or what you see down below. So how do you change this table for an inverse? You have an inverse, what happens to the columns? They switch. Exactly. That's why I call inverse. They switch. So that's exactly what I'm gonna do. I'm gonna switch them. 1/10 and -1. 1, 0, 10, 1, 102. Perfect. So you have 1, 0. 1/10, -1. 10, 1 is way up there in yonder. Whoa, 100, 2. It's way out here. So clearly this is not to scale. That's okay. There's your graph, right? Not that hard. So that's exactly what you have to do. Log graphs always look like this. Their domain's always going to be all real numbers. No, sorry. The range is always going to be all real numbers. The domain is limited. And of course, there's a vertical asymptote, not horizontal. That's always true for log graphs. And that's x equals 0. So it's all reversed from exponential, right? Because exponential would look like this, right? You don't have to draw the exponential, just doing a quick sketch. But that is a horizontal asymptote at y equals 0. That domain is all real numbers. And the range is from 0 to infinity. Right? Okay, we're all good? Okay. So, yeah, we'll just, there's a lot of repetition. I don't feel like doing all these. I don't know. I'll have to do something kind of quickly because this is going to be very droning. But anyway, here's what I would do. Changes to that. In order to make your life easier, switch that to exponential form. You have to pay that. That makes sense. This is the whole basis of the log, right? And then y is the exponent. So y is the input. So by doing the switch, so let me actually, I hate saying cookbook recipe, but I will do that. So what you want to do is rewrite as an exponential equation. Treat y as the input and x as the output. After making your table, plot the points. However, there are any transformations Okay, sorry if you can't read on that, but so this is going to be the process for all the problems today for the homework. Rewrite an exponential equation. Treat y as the input and x as the output. After make your table, plot the points. So if there are any transformations, then create another table by applying those transformations and plot those points. And let me actually make a small for the parent function, because we're not going to do that if it's not a parent function, because it's going to be too complicated. So rewrite as an exponential equation for the parent function. This is already parent function, so we're cool there. But that's what you want to do. So, excuse me. So now let me plot those points. So I always like to do these here. Those are very simple. 3 points is enough, guys. I'm cool with 3 points. 1/2, 1, and 2. Plot it. Boom, boom, boom. Good. Domains from 0 to infinity. Range, all real numbers. X-intercepts clearly at 1. As it says x equals 1. Let's write the x-intercepts order pair. It's always increasing. So from 0 to infinity. Let's see, flip it. Decreasing, never. And behavior. I'm going to write like this. Because you guys are very close to taking calculus, so I'm going to write like this here. And I'll explain what all this means in just a moment. Okay. So this is called limit notation. Excuse me. LIM is short for limit. X arrow negative means x is going towards negative means x is going to the left. As x is going to the left, what's y doing? Is it pointing up or down? So we say negative infinity. Because clearly, if I make x forward, actually, I lied. That one. Can x go towards negative infinity for a log? What's my domain here? Yeah, and actually, I need to say it like this. It's a little confusing, so let me explain what this means in layman's terms. That means x is approaching 0 from the right side. So if approaching 0, I should know that I teach calculus. I did that mistake. If approaching 0 from the right side, what's y doing? It's getting more negative. Like if I plug in like 0.1, 0.01, 0.001, 0.0000000000001, like it's so close to 0, but not exactly 0. And to the right shows positive. What's y going to do? It's going to shoot down forever. So that's how you express time behavior. This is actually calculus 101. When you start calculus for the juniors here, do calculus here from mid-late August. Day 1 is what we do. We do this. If you're a senior, you go off to college, and whatever college you go to do calculus, your professor. Day 1, they're going to talk about this. Just see. Now this means x approaching thing, which you can do because x does go towards the thing. What does y do? It just keeps going up slowly, but surely. It's just going to go up forever. So if you want to write it as as x does this, y does this, that's fine too. But I want to get a habit of writing this way because that's the custom for calculus. Okay, let's keep going. Let's do one with the transformation. Yeah, what the heck? We'll do all these because I think we should. Okay, so here's what I do. Your parent function is y equals log base 1/3 x. Why do I call it the parent function? How does it compare to the original? What did I draw? What did I draw from the original? The plus 1. Because what does that plus 1 do at the end? What is that responsible for? Shifts it up, right? For now, let's not worry about it. For now, let's worry about just the basic. It's kind of like if you go buy a car, like, yeah, it's great. You have cooled seats or heated seats or a moonroof, sunroof, or satellite radio, or I don't know, other cool stuff that a car has, or like Bluetooth, whatever. But just say it's the most basic car, like you're not going to spend that much money, right? So anyhow, so I'll do this again. The range all real. Wait. Sorry. I have to make a new table. Because what's our true equation? Yeah, so you have to add 1 here. My apologies. Got a little too carried away there. Okay, now let's do it. 3, 0, 1, 1, 1/3, comma 2. Okay, that's still going to be 0 to infinity. I wasn't wrong about that. Wasn't wrong about that. The y-intercept, the x-intercept, that's where I caught myself. Because I realized, wait 1 sec, that doesn't make sense. So we'll put it as an ordered pair. Asymptotes x equals 0. Now this is never increasing. Because why is it never increasing? Before it was. What was different about this one compared to the previous example? Look at your base here. Is your base bigger than 1 or less than 1? Your base is what? Less. That's decay. Even though this is a log function, it's still like a decay function because it's the inverse of an exponential function. So it is that. And then when I do my end behavior, again, I'm just going to start doing this fashion here as x approaches 0 from the right side. So that superscript means right side. If you put a minus, means left side. F of x, sorry, h of x. Clearly that's going towards positive infinity on the left side. On the right side, it's going towards negative infinity. So as x approaches positive infinity, or you can write infinity, that's fine too. It's implied it's positive if you don't put a sign there. Negative infinity. There we go. So that's the process you want to go through. And again, this is all recorded too. So if you ever have to watch this recording, I don't know when we'll have a test on this. I have to talk to the Precalculus team to see when. My hope is we'll have a test probably at the end of April, beginning of May. I have to look at the calendar. Definitely before AP season, because I think AP season is going to be pretty crazy. All right, let's keep moving. This one here, what are the transformations here, guys? Yeah, it's the minus out in front and the -2 on the inside. So I'm going to start with this as my parent. X equals 3 to the y. I'm going to keep doing this. Sorry, we want to adjust the table. My bad. So we adjust the table. We have to add 2 here and multiply by -1. Do you see why? What does a -2 do, guys? You guys know this. Shifts it to right. And what does a minus do on the outside? It reflects. So let's shift to right. When we say flip, I know what you mean, but we want to be a little more formal with our language. Reflect about x-axis. That's more formal. Because flip could also mean flip out the y-axis, right? I mean, that's a possibility. So we want to be more formal about it. So now, um, 2 1/3, 3, 5, 1, 0, -1. And where's the vertical asymptote going to be? Because that shifts, right? You got to shift to right. The range is all real. X-intercept is 3, 0 again. Okay, interesting. Yeah. Asymptote x equals 2. Never increasing the way it's set up because we flipped it. Increase from 2 to infinity, decrease from 2 to infinity. When I write my limit notation, my end behavior, we're approaching 2 from the right side. This is k of x. That's going towards positive infinity. And positive infinity, negative infinity. So, yep, we're all good. Okay. Don't freak out when you see ln x. A lot of students freak out when they see it. Ln is the same thing as saying this, which is the same thing as saying this, which is the same thing as saying this. (2.718 raised to the x power). So when you plug in one, sorry, to the y power, my bad. So when you do this, that's going to be 2.718. That's going to be 1. And that's 1 over 2.718, which is roughly a third. So 1, 0. Domain's all real. Range, sorry, domain's all real from 0 to infinity. Wow. Sorry, a little tired today. X-intercept is 1, 0. As to x equals 0. Is always increasing on its interval, never decreasing. Asymptote, when we draw it. And behavior. Approaching 0 from the right side. Okay, all's good? Yep, okay. I'm just gonna tell you what happens for 5. This is getting very cumbersome. Clearly you're going to shift 1 down. And here, you're gonna vertically stretch by a factor of 3. Okay. Excuse me. So in this case, let me think here. Vertical stretch by a factor of 3, shift 1 down. So the way you're going to impact y is you keep x the same. But multiply y by 3. Then subtract by 1 to new y values. Why do you multiply before subtracting? PEMDAS, thank you, Sean. Yes, that's correct. Yeah, that's it. And yeah, that's all you do. So I'm not going to do it because if you guys get the idea. Okay, just more review of old stuff. Remember, anything up top is positive, anything down below is negative. So it'll be like this. And the 1/2 rolls to the front because 1/2 power. You can actually clean it up too, but I'm just going to do that. Does that make sense? Okay. And then here you want to bring it together. Let's see. Right, because you got to move the 2 to the back and the 4 to the back. But then you have to multiply them as well afterwards. And if you want to condense it even more, you can say log base 3 of 16 V6. Okay. And lastly, if it's depreciating, you should know that it's going to be set up like this. 46,500 is your initial value. 1 minus 0.09. And it's depreciating each year. 60 months time of years, guys. 5, right. That's usually how cars depreciate, usually by about that much. And I got to work that out. Yes, the car's worth this much after 5 years. So cars are not really the best investment, just so you know. I mean, it's good to have a nice car. You need a car to get around. Don't get me wrong. Usually not the best investment though. There you go. Well, so that's just kind of review of old stuff. All right, perfect. Yeah, we still got another what? Yeah, so you guys can just get homework done if you guys want. The answer key, let me print and make one. I don't know if one has been created. And I'll stop the recording.